so this is going to be a technical presentation, so hold on to your shoes. So this is something we had a few months ago, an idea that we should integrate with Twitter, of course, and as you will see, there's an easy way to do it, and there's a more complicated way of doing it, and I'm going to show you the complicated way of doing it. So the goal is to show you some Elixir and OTP in action, basically. Consuming an external API, dealing with a stream, and hopefully some tips along the way. There are some assumptions. I assume that you know a little bit of Elixir. Who's here totally new to Elixir? One person, two person, okay. Well, I think hopefully you'll probably get it just by looking at the code, because it's a little bit similar to Ruby. It's a little bit easier to read than Erlang. Some gen servers, notions. I'm not going to explain everything about gen servers, but I think you will get much of it. Supervisors, the streams, and the WebSockets. So we're going to break this in two parts. The first part will be the OTP only part of it, and the second part we're going to integrate what we do in the first part on the website. So these are the requirements. As Nicholas described, we're going to implement this recent updates there, the list there. And option one, of course, is to use whatever Twitter provides as embedded timelines. It's super easy to integrate. You just go on the Twitter website, you just enter your URL for your Twitter timeline, and you get a code snippet that you just put in your HTML page, and that's it. And that's what you end up with. So that is too easy for a presentation, so let's do it with the option number two, which is the using the Twitter API. So they have a great search API, and we're only going to scratch the surface of the API and just use the tweet search and the user timeline, but there's a gazillion functions you can use from the Twitter API. And it's at the developer.twitter.com. It's really well documented. So this is great. I mean, it's a great API to use. It's all JSON based. So is there anything out there that we could use as far as a package for those who are new into the Elixir world? A package is similar to a gem in Ruby. So let's go on x.pm. This is where it's like rubygems.org, and let's search for Twitter, and we end up with 6 packages, and it's the first one we want to use, the X-Twitter package, a Twitter client library for Elixir. So if we click and go on their GitHub page, we see that it's pretty easy to use. I mean, we just add the X-Twitter dependency to the mix file, we configure it, and we just use it. That's pretty simple. Now, let's do it. So this is the architecture we're gonna follow for the rest of the presentation. So we'll start with Twitter. Twitter will ask Twitter to give us the most recent tweets from the user. And we'll also connect to one of the stream, and that would be the user timeline stream. So what we will get from Twitter will go through an adapter, because we want to decouple our code from the package we're going to be using. So we'll talk about that a little bit more later. And that will feed the timeline. So the timeline will be a gen server, something that will be living all day long on the server. It will be fully and always connected to Twitter via the stream. And the latest tweets there, we're going to query Twitter for the latest tweets when we start the app, basically. And then when the app is started, the timeline will keep track in its state of all the tweets, of all the new tweets. So we'll have a stream reader here. The stream reader will get the new tweets from the Twitter stream. And we're going to use PubSub to publish new tweets. So the way we are going to do this is the upper part there, that will be a OTP app. It's a standalone app, no UI, nothing. It's all command line if you want. So you can do in the console, you can ask the timeline, give me your tweets, you can subscribe to the pub sub, and we will be receiving new tweets. So this is to decouple from any UI. Then at the bottom there, that will be the web application, and the web application will be consuming the events that we'll get from the Twitter app. So above there in the graphic, that will be addressed in the first part of the presentation, and the bottom part will be addressed in the second part. So we're going to start by creating a Twitter umbrella app. So for those who don't know it, in Elixir, there's a way of structuring projects. They call that an umbrella app. And within the umbrella, you can create additional apps. And each additional app is encapsulated in its own folder. It's easy to extract into a package if you want in the future. So we're going to create an umbrella app for the Twitter part of it. So it's a standalone OTP application. It will be publishing events to the pub sub application, and of course we'll need some configuration for using the Twitter API. So to create the new application, we go under the apps folder in the project, and we just do mix new Twitter -- sub. And the -- sub here is to generate a supervision strategy in the application boot sequence. So these are all the files created, and this is where we have the supervision tree there in the application. And just to give you an idea of what it looks like, we have the Twitter application, and when it starts, we can define workers here. So eventually we'll add some workers here for the timeline and eventually for some listeners. Any questions so far? Yes, there's a question there.
I promise I won't be asking questions all night. But just to clarify, so we already have an umbrella application and we're creating a child under that?
Exactly, yeah, right. Yeah, we're creating the child. This is a child in the umbrella application. Exactly, yeah. Good question. So the features of the timeline would be, first, we need to get a list of the most recent tweets. So this will be happening when we boot the application, when we deploy the application, when we start the console. We need a way to publish new tweets that we receive from Twitter, of course, and we need to handle deleted tweets. This is a nice to have. I won't go into the details of handling deleted tweets tonight, but what will be deployed in the next couple of hours is handling the deleted tweets, and you can have a look at the source code. So we're going to be focusing on this part of the architecture at the top there. So the adapter, getting the latest tweets, and feeding that to the timeline. So the adapter pattern, it's a way to decouple your code from something that you use to interface with an external API. So this way, you're not tied to the data structure of the package you want to use. And this way you use your own data structs. And you can have your adapter implement a behavior that you define. So this is what we're going to be doing. So if in the future we want to use another package other than xTwitter, it will be an easy swap to do. We just need to change the adapter and comply with the behavior and the data structs that we will define. So that's an example of a struct we need. We only need three things: the ID of the tweet, the text, and the timestamp. That's all we need for now. So this is what our code, our timeline will be using. And in the future, a tweet deletion where you have the ID of the tweet that has been deleted. So we need also to define a behavior. So this is the adapter behavior we're going to be using. Like I said, the adapter has two responsibilities: fetching the user timeline and getting the user stream. And this is the type spec notation. Type spec is a way to define the specification of functions. So this is saying that the function fetch user timeline will be returning a list of tweets. So the structs I just showed you here. So this first function returns a list of tweets, and the second function will be returning a stream. All right? And by the way, a stream, this is a core data structure in Elixir. So we're going to test drive the timeline. All right, so again, this is what we'll be focusing on, the adapter getting the latest tweets and fetching that to the timeline. So, of course, when we run the test, we don't want to hit the Twitter API all the time. And especially when we just want to test the behavior of the timeline, the functionality of the timeline. So we're going to write a fake adapter. And the test will provide dummy data to the fake adapter, and the Twitter timeline will be using the fake adapter in the tests. And later on, we can test the X-Twitter adapter using a different tool set. So let's do some setup. So this is the timeline test. We have a setup block. We need to define the adapter. So we define the Twitter adapter fake. We're going to start the adapter. So this is starting a process for the adapter, because X-Twitter, the package that we will be using, is basically a process running in the background. So we need to simulate that with the fake adapter. And when the test ends, we're going to wait for the adapter to really be down. This is to prevent having multiple tests that would, because of some timing issues, would be talking to the wrong adapter that is shutting down, whatever. So this is to make sure that whatever background process you have is really down when the test is over. And this is, I took this from the Elixir forum. It's how to stop OTP processes started in X unit. So it's a nice little tip. So now this is a real test, initializing the timeline. So what we want to test here is that when we start a timeline, we expect the timeline to ask the adapter, give me the latest tweets. So we're going to push some tweets to the adapter. So this is a utility function we wrote in the adapter. And by the way, I'm not going to show you the fake adapter. It's a bit complicated set of code. So you can have a look at that later. So we start the timeline, we pass the adapter to use, then we ask the timeline, give me your tweets, and then we assert that we got 2 tweets, and the first tweet is in fact the one that we provided here. Nice and simple. So of course the test will fail because we haven't written anything. So we need to write the timeline. So the timeline is a gen server. So for those who know, a gen server, you need to start it, and this is the boot sequence of the of the gen server, and this will eventually call the init function, and you pass to the init function whatever you want to pass for initialization. So I won't go into details of gen servers because it's a bit complicated, but this is, the startling is ran in the context of the caller. The init is called in the context of the gen server process. So it's a different process. And we have a question or a comment.
So I guess the init function is a callback as well.
Yes, it is a callback. Yeah. So probably it should be under this comment here.
I never really thought about that before.
Yeah, you missed that in the code review, Nicholas. Shame on you. All right. So what are we doing here? So we are getting from the application configuration the adapter, and we default to the one that we receive in the options. And remember, we did pass the adapter in the test here. So this is basically one element in the options. So we're getting the adapter here, and we're starting the gen server, the process itself. So when the process starts, it gets initialized, and then we are deferring the initialization to prevent some timeouts. This is a special trick. There are a lot of 5-second timeouts in the OTP, the beam. So just in case it would take some time to connect to Twitter, we're going to defer the initialization by sending to the gen server a init message. And when the process gets the message, it will do its initialization. So it's basically fetching the user timeline from the adapter, and I clicked, and then it sets the state. And the The beauty of the Gen server is to keep track of a state. It's a process that you interact with, and the process keeps a state in memory. So every callback has the responsibility of always providing the new state. Even if you don't modify it, that's fine, but you need to provide the state in the reply. Any questions so far? All right, so this is just setting up the Gen server. We don't actually, well, no, we do get something here. We do initialize and get, and we fetch the user timeline. But now we need a way to get that list of tweets. Here, it's only initializing, so there's no way we can ask the timeline, hey, give me a list of tweets. So we need to implement the tweets function. So we are still in the Twitter timeline, Gen server. We are adding two functions. This is the public interface of the timeline, so it's the tweets function. And this calls a callback within the Gen server process. So this is a very simple list function. So we're just going to pattern match on the state, get the tweets, and return the tweets. All right, so that's one of the most simplest callbacks you can implement for a Gen server. Yep.
How do you see it's public? How do you see it's public?
How do you see it's public? Good question. In Elixir, when you see def here, if you see def p, it's a private function. This is a public function. So it can be used from outside the module here. But as you can see here, the handle call is also a public function. But it's not meant to be called by clients of the Gen server. This is a handle call. It's a callback used by the Gen server. Most of the time, the public functions that can be called in the Gen server are at the top of a module. And all the Gen server callbacks are at the bottom. This is a convention we use, especially. Yeah, but yeah, it's different because you need to remember this is a different process. So the communication between process is done via messages. So when you call the tweets functions, it's basically sending a message to the process. And the process, when it gets the message, it calls handle call. And with the message it got, and then it needs to reply with another message. So it's message passing. So, need to wait for the mic. We have some latency in the question process.
You almost answered my question, but are calls serialized?
Yes.
One after the other?
Yeah, all the messages, yeah.
Okay.
The message queue of a process is sequential. First message in the queue is processed first. Yep. And that's why the initialization here works, because I'm sending myself an init message, and even though someone could call the tweets function, it's going to be the second message always, because this will be the very first message, and we're guaranteed that it will be processed first. All right, so the test is green, and we have a feature implemented. And now we need to make it work with the real adapter, the X-Twitter adapter. This was using the fake adapter. We were basically testing the timeline logic. Now we need to focus on the real adapter. So again, we're going to switch this adapter to the real run. And again, the adapter has two responsibilities: getting the user's timeline and providing a stream of incoming Twitter messages. And it also has the responsibility of converting the X-Twitter structs to our own structs. And as you will see in a few minutes, let's forget about this one. All right, so this is the implementation of the X-Twitter adapter. So it's implementing the behavior that we saw earlier, the Twitter adapter behavior, and we have two functions. And again, this is very similar to what we had in the behavior. The function needs to return a list of tweets, and the other one needs to return a stream. So right now, it's not doing much. Let's add some code in there. So first, we need to convert the data that we receive from the X-Twitter package. So we are writing a test here to take the xTwitter model tweet struct, and we're going to pass some data here. We're going to call a convert function in our own adapter of xTwitter, and we're going to make sure that it matches the tweet we're expecting here. So here it's pretty similar. The only difference is the created at here. We use a timestamp name here. So first, we need to add xTwitter as a dependency to the project. So that's the first thing to do in the mix file. Then we run the mix.get. It's like the bundler equivalent in the Ruby world. And now we need to add that function, that convert function. So this is a nested module within the adapter, since this is very specific to the xTwitter adapter, so I decided to add a sub-module in there just for dealing with the conversion. And it will receive a xTwitter model tweet struct, and will spit back a Twitter tweet with the data we're expecting. Very simple. So for those who are new to Elixir, this is called pattern matching. We could have many convert functions and change the signature of the function. So this is pretty handy. The pattern matching in Elixir is one of the key features of Elixir, so that's something you're gonna love a lot. So we fetch a user timeline calling the xTwitter user timeline function, and then we're just enumerating over the list, and we call the convert function that we have here. So this is basically converting the tweets we get from xTwitter to our own tweet structs. So let's try it. But first, we need to configure stuff. Yeah, that's the painful thing. I don't like configuration. All right, so first thing, this is the main configuration file on the website project. So we need to add a configuration here, and this is our own configuration. We decide however we want to call it. So I decided to call it adapter, and we specify which adapter to use. So this is the default adapter to use, the adapter we just wrote. We also need to go in the development config and import some secrets. So we import another config file in which we will put the consumer key secrets and the tokens that we'll get from Twitter. So at this point, we need to go on Twitter and do some setup. So you go on apps.twitter.com, you create a new app, and then you will have access to the tokens. So it's pretty simple. You just give it a name, description, the website URL, and blah, 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 blah. I mean, boilerplate. All right, time to do the first demo. And this is where things crash normally. All right, so demo one. Okay. So this is going to be in the console. So I'm going to start the Elixir console -smix. All right, so what do we have so far? We have a Twitter namespace. We created a timeline, and we're just gonna start it. All right, so we have a timeline started. What are we expecting from the timeline? We're expecting the timeline to give us a list of tweets. And how do we do that? Well, we just call the tweets function, if you remember. Timeline.tweets, and hopefully we'll get a list of tweets. Yeah, we do. So if you want to look at the first one, let's take the first 4. So that makes sense. Come and get your tag. We're looking for a person to help us with beverages. Yeah, so those are tweets from tonight. So this works. Any questions so far?
I'm wondering how could you have like many timelines? You have to do special things in the configuration, that kind of stuff.
Good question. The question is, how easy would it be to have multiple timelines? Well, you can have, well, the timeline I wrote is for one specific server user because I give it a name. I don't know if you noticed, but I give a name to the process and it's a unique name. But if I was not giving it a name, we could spawn as many timelines as we could, but we would have to provide the timeline with a user ID to use on Twitter, or we would need to pass some configuration. Right now, it's using the tokens and the secret key of the user that created the app on Twitter. So it's using the Montreal Elixir user. So that's why it works. But if you want to have multiple timelines, you need to pass credentials to the process, and then it could connect to it. Yeah. The X-Twitter, you can configure X-Twitter to, well, thinking about that a little bit more, I'm not sure if X-Twitter, because X-Twitter is a process running in the background. It's an OTP app. So I'm not sure if you can start many of them. So that's something to look at. All right, let's move on to the stream. So, again, this is the architecture we are following, and we'll be focusing now on reading the stream and pushing those new tweets to the timeline. And the timeline will publish some events here, and we will have eventually a listener for those publications. So we need to test that. So we're back in the timeline test. We have some setup to do now, because now we have to deal with PubSub. So we're going to start PubSub. We're going to subscribe to a topic, and that will be the test timeline topic. So we're subscribing self, which is the process of the test. So the test process will be subscribed to the PubSub. We then start the timeline with the fake adapter and the topic to use. And then we have our small utility to assert the timeline is really down when we exit the test. Now, the real test is, I have a tweet. I have my fake adapter. I have a utility function in there to fake a stream, like fake streaming the tweet. And then we are asserting that we received a message, new tweet, with the tweet we specified here. It's only 3 lines of code, but there's a lot going on here. So we have something simulating the stream, the X-Twitter stream, and then here we're asserting that PubSub sent the new tweet message. So we need PubSub in the project. So we add PubSub as a dependency. We run mix.deps.get, and then it's time to implement this. So we need to change how we initialize the timeline. So now we're getting a topic, and we need to pass this down to the init function here, and we're going to store the topic to use in the state of the process here. So then we can forget about the topic. The gen server, the timeline has been initialized with the topic to use eventually. And of course, we still have the empty list of tweets and the adapter. Now, when we really initialize the timeline, remember this is deferred initialization, so now we need to listen to the user stream. So we got the adapter to use, so this is a function. We're asking the adapter, I don't know if you remember, but the adapter has 2 responsibilities, providing a list of existing tweets and providing a stream. So we're asking the adapter, hey, give me a user stream. And then the timeline is ourselves. And then, this is the tricky thing for someone new in Elixir, we're spawning a task, and the task will call this function. And the read stream function will receive the stream we just got from the adapter, and will also receive the timeline. So we're forking another process. It's called a task because in Elixir they encapsulated some process thing in a task module. So we're basically just spawning a process just for reading the stream asynchronously. So read stream, that's a function we have to implement. So what is this? So we're getting a stream, a timeline, and then we have a for loop. This is called a comprehension in Elixir. So in the stream, for each message, it calls a function, determine call message, and based on the result of that function, if it's a no op, yeah, it's okay, we don't do anything. But if we do get an action, we'll send the action to the gen server, the timeline. So, so what can be the action? Well, for now, if we do get a new tweet, we're just gonna send this to the gen server, the timeline, push tweet. Any question? This is a bit funky, yeah. Well, defp, the question is, what is the defp? That's a private function. That's the private function, and this function can only be called in the context of this module, the timeline module. So it's called here. So we have two processes here in the picture. We have the timeline, we have the task that is reading constantly from the stream. And when it gets a new message, it sends a message to the timeline, hey, here's a new tweet. So we need a timeline to handle that new message. So we need a handle call, again, that's another callback, with the push tweet message that we got from the task reading the stream. And this is where we're just publishing the new tweet we just got. So we call pub/sub, publish on the topic, the new tweet and the tweet we got. And since we want to keep a list of all those tweets, we need to change the state. So we need to add the tweet to the tweets we already have in the state. So this is all done here in this function here. No question? So I see some people maybe being lost. Don't be afraid to ask questions. So, so the get user stream in the adapter for the real package we're using, xTwitter, it's simply calling the stream user function from the package, and we need to give it some arguments here, timeout infinity, so that it's constantly reading the stream. And when we get messages from Twitter in the stream, we get all kinds of messages. We just don't get tweets. We get deleted tweets, we get retweets, we get some social information. I mean, there's a bunch of messages that we get from the API. So we need to filter that stream. So remember, we have a submodule called state, and so we need to add a filter stream just to remove the crap and just keep the tweets. Question?
Like under the hood, this is opening up a WebSocket, or?
No, the question is under the hood, is it opening a WebSocket? Not at this point. Well, maybe it's open. Maybe I would have to have a look at the xTwitter source code. It's probably calling using a socket technology, right? Probably, yeah. Yes, most likely. Anyone has the answer for that? No. Yeah, I would imagine so, because it's a JSON. It's a JSON API that Twitter provides, so it's probably meant to be used by JavaScript code. So most likely it's a WebSocket. So we need to implement the filter stream function. So it gets a stream, and this is kind of nice in Elixir. We have stream functions we can use. So this one is a filter. So it will only pass through the elements of the stream that are valid. In this case, if it's a tweet that we get in the stream, we return true. Otherwise, everything else, it's false. So when this function exits, it will only return a list of tweets. Everything else will be filtered out. And then we go through the list of tweets and we convert them to our own data struct. All right. All right, so, and while we're in the code, we might as well start the timeline automatically when we boot the application. So we're back in the Twitter application module here, and we're gonna set a list of children. So how this was implemented is by calling the function, we pass the environment we're currently running on, and if it's test, don't start the timeline, because we want to start the timeline manually in the test. Otherwise, start the Twitter timeline, no arguments, boom. So, the second demo. Oops. whoops, I need to exit, clear, demo 2. All right. So the minute I start, x minus x, mix. All right. So since I configured a worker, I don't have to start a timeline. It's there. And as a proof of concept, I can just ask it, what Twitter timeline.tweets, the same list of tweets as we had before. So what do we want to test here? We want to test the pubsub of stuff. So we're going to subscribe to the topic there. So subscribe self, and this is the topic. All right. So what this does, it's adding our PID, the console process ID, to a list of subscribers, PubSub. So when we call flush, it flushes the message queue. So if I had any message waiting to be read in my process queue, I would see it there. It's not there. So now we're going to need a volunteer to publish a tweet. So Nicholas will gladly tweet something. It's good? Live demo at Montreal, Elixir. So yeah, and if I do flush again, no new tweets. And if I ask again the process, give me your list of tweets, well, that will be at the top there. So if I take the list that first. So it's a process that keeps track of all the tweets that will be incoming. And all right, any question here so far on this? I'm going to show you something. Maybe some people didn't see the observer, and this is kind of cool. This is something great about the Erlang platform. So I'm going to start an observer. So this is a graphical way of looking. It's a little bit small here, but so we can see a list of all the applications here, and you see we have the and I lost my cursor. Okay, we have the X-Twitter application, and we also have Twitter. This is our application, and we can see we have the X-Twitter supervisor. We have our timeline right here. So I could go in there, double click on it. No, it's not double clicking. What happens with my fat cursor? It goes away. So I can kill the process. Let's say it's crashing. It got an offending message from Twitter, and it crashed. Kill. So the supervisor restarted the timeline. We have a new PID here. Everything is fine. So I should technically just go here, ask for the tweets, and it all works. This is the magic of Elixir. The supervision tree and the auto restart of processes that dies. This is awesome. All right, any question? So I think we are at the point where it's a break. So we're going to take a short break, and then we'll hook this up to the web page. All right.
Do you mind just a question?
Yes, question.
So you show that if you flush the Twitter timeline, you see the latest tweets, right? What happens if the process crash and you launch it again? You will see the latest tweet again?
Yeah, the question is, if the timeline process crashes, do I lose all the tweets I had in the state? Yes. So when it restarts, when I killed it, the supervisor restarted the timeline process. And remember, I have a init function that calls get latest tweets on the adapter. So when the process starts, it initializes and it asks the adapter, give me the latest tweets. And it puts that in the state. So it will auto recover if it crashes. All right. So we're going to address the bottom part of this architecture here. So we're going to focus on the timeline channel. So maybe some of you will be more familiar with this. This is JavaScript WebSocket stuff, and you're going to see how this is implemented in the Phoenix framework. So we have to deal with an HTML container for listing the tweets, some client-side JavaScript code for consuming the WebSocket. We need a listener on the server that listens to the new tweets, and we need some channel logic for talking to the client. So HTML is pretty simple. As usual, we just put some HTML code with some IDs and classes, and boom, that's it. Nothing really fancy. In the app.js, we're going to write our own small Twitter timeline JavaScript module there, object, I should say. And we're going to initialize it with the socket. This is all provided by the way, by Phoenix, the socket library here. So we just import the socket and pass it to the initialization of our object here and the container in the HTML code. And this is pretty simple. We just get the channel, the container, we join the channel here, and then when we get a message down from the server, updated list, we're just gonna refresh all the tweets we have in the list there. So this is pretty simple. I won't spend too much time on this. So the thing important here is the join and the on updated. So we need something equivalent on the server side for those two callbacks. So on the server, we need to set up the channel. So this is the name we're using, the JavaScript code. And this channel will be handled by the tweets channel module. This is the Elixir module that will be dealing with this channel. And this is what it looks like. So when someone joins the channel, we're going to send, again, ourselves a message after join, and the message we got was from the browser. And here, what we're going to do, we're going to ask the timeline, hey, give me all the tweets you have, and we're going to push that list to the browser. Very simple push to the socket, updated list, a list of tweets. Boom. That's it. And that's all. That's so easy to use a WebSocket in Phoenix. So let's demonstrate this. So let's quit the console here. Demo 3. All right. Notes here. So we're going to start the Phoenix server. So nothing is running. We don't have any timeline running right now. So let's start the server. Mix phoenix.server. All right, it is started. The timeline has initialized. It asks Twitter for the latest tweets. And if I refresh here, I should get a list, and I do. So those are the most latest tweets. And yeah, Nicholas wants to send us another tweet. Well, Nicholas, don't send one because that won't work anyway, because we only implemented getting the list of latest tweets. So yeah, yep. So if I refresh the page, as you can see, there's a small glitch here because it's all JavaScript driven. There's nothing in the HTML code. So we need to connect to the WebSocket as the server to join the channel, and the reply will contain the list of tweets. Questions? Now, we need to handle the stream, and this is where it's getting interesting. So again, we're focusing on the bottom part here, but now we need to consume the events that we will be receiving from the pub sub. So we need a listener. So what should be the listener? Any guess on how we should implement a listener?
Subscribe to the pub sub?
Yeah, what will be subscribing to the pub sub? A gen server again, so we'll be writing another gen server. So the listener needs to subscribe to the pub sub topic, we're gonna give it, and it will broadcast events on the channel, the WebSocket channel. So it's a middleman between the timeline and the WebSocket talking to all the browsers. So as you can see, this is very similar to what we have in the timeline. It's a gen server, it's a start link, we start it, we initialize. Now this is a simple initialization. We don't need to defer the initialization, so we can do the initialization right here. So we're subscribing ourselves on PubSub for this topic. And when we get this message, a new tweet, we ask the endpoint to broadcast a message on the channel here. That's basically it. That's all it does. So it's a process running all the time on the server, listening for new events, and just pushing and broadcasting to all the browsers connected to the server through WebSocket. So, since this is a long-living process, we need to start it at some point. So, in the Montreal Elixir web, we're now in the web application in our website project. We go in the application module and we add a new worker. So, the worker is the Twitter timeline listener that we just wrote. And then on the client JavaScript code, we need to add some handling here for the new tweet. So when we get the new tweet message, we call the new tweet function and we prepend the list with the tweet we just got. So far, it's easy. One last thing there. We need to add a dependency to the Twitter app we wrote before the break so that it gets started before the web app. And why is that? It's because our web app will subscribe to the PubSub, but the PubSub process is started by the Twitter app. So we need to make sure the Twitter app is started first. So we can do that by adding some dependency here in the Elixir web mix file. So we're saying, hey, the web app depends on the Twitter app that is in the umbrella. So when the web app starts, it will make sure the Twitter is started first, and we'll have the PubSub process started, and everything will be well connected. And demo number 4. No question? All right. Demo 4. All right. So let's restart the server again. Let's clear this. If I refresh this, here we go. So I applied some of my CSS skills, limited skills, to the list here. So now if Nicholas tweets something new, yeah, here we go. It was faster than I thought. Yeah, oh, and an emoji as well. That's cool. Yeah, so that's how it works. So if I refresh the page, I only get the last 3. This was part of the requirements to only show the most 3 recent tweets. Any question? So what would be next? I don't know if you noticed, but the timestamp is in UTC format, though that would be a nice contribution if someone wants to have fun and format the timestamp there. Well, that would probably have to be done in JavaScript anyway, so. We need to get the full text as well. Currently, I don't know if you noticed that, but the tweets are truncated. Well, there's no example here, but there are some long tweets. They get truncated. Twitter is doing that by default. It's truncating the long tweets, although it's only 128 characters. Well, 140? I know. Anyway, I don't know why you do that. 280 now. Anyway, so, but I quickly took a look, and I think there's an option we can pass when we initialize xTwitter to get to get the complete text from the tweets. Or maybe it wouldn't work, and xTwitter will need some contribution from the community. We'll see. Maybe use XVCR. This is like VCR in the Ruby world to better test the X-Twitter adapter. So maybe we could capture some real API JSON from Twitter and run the test on top of that. So that's something to experiment with. Otherwise, we can just easily test the adapter in the console, as you saw. So that's it, 8:30 sharp. All right, well, thank you again for attending.